The Reiner Gamma marking on the moon looks like a bright swirl painted onto the gray dust by an invisible hand, and in over 50 years of watching it, no human being has ever caught it changing shape. Scientists spent decades assuming the moon was a dead, silent rock with nothing left to explain, and that assumption turned out to be wrong in almost every direction they checked. Stick around, because what buried instruments picked up underneath the lunar surface is stranger than anything a science fiction writer ever guessed. Now, before we go further, if uncovering the real documented secrets hiding under that gray dust and vacuum silence is the kind of thing you do not want to miss, subscribe now, because this channel tracks every new finding about the moon's hidden activity the moment researchers actually publish it. Here's the strange part nobody tells you in school. The moon has no thick atmosphere, no weather, no rivers, and no obvious engine driving change. By every simple definition, it should just sit there, unchanged, forever. But seismometers left behind decades ago recorded the ground itself trembling, shivering, and in one case, ringing like a struck bell for almost an hour. Something inside that gray, silent rock is still active, and scientists are still arguing about exactly what it is. Ancient astronomers noticed flickers of light on the moon's dark side centuries before anyone had a telescope powerful enough to explain them. Modern instruments have now caught similar glows near a crater called Aristarchus, and nobody has fully explained those either. So this is not a new mystery invented for a video title. This is a mystery that has followed the moon through history, and it is only getting stranger as our tools get better. Astronomers even have a name for these flickers now: transient lunar phenomena, a formal label for a very informal, very stubborn mystery. Reports go back hundreds of years, long before spaceflight, with observers describing faint red or orange glows, hazy patches, or brief bright points appearing and then fading within minutes. For a long time, these reports were dismissed as tired eyes, bad telescopes, or simple imagination. Then modern observatories, watching the same regions with far steadier instruments, started catching similar flickers on camera, which made the old dismissal a lot harder to defend. Let us start from the beginning, because most people carry around one big wrong idea about the moon, and it shapes how they think about everything else. Most people picture the moon as a finished object, cooled off, cracked, and completely done changing, the way a cake is done once it comes out of the oven. That picture is wrong. The moon is still shrinking, still shifting, and still occasionally trembling under our feet, or rather, under the feet of the astronauts who once stood there. It is not dead. It is just quiet in a way that fooled us for a very long time. To understand how we even know this, we have to go back to the Apollo missions, because those astronauts left behind more than footprints. Between 1969 and 1972, NASA crews planted a small network of seismometers on the lunar surface. Instruments built to detect the faintest shiver in solid rock, the same basic idea used to detect earthquakes back home. Nobody expected much. The plan was to let them run for a few years, collect background data, and quietly retire them once the funding ran out. Budget cuts nearly ended the whole effort early, and NASA actually shut the network down in 1977, years before anyone had finished digging through everything it had recorded. For decades afterward, that data sat mostly untouched in archives, reviewed by only a handful of specialists, while the wider public assumptions settled comfortably back into thinking of the moon as finished business. It took modern computing power, decades later, to properly comb back through those old recordings and notice just how much unexplained shaking was quietly sitting there the entire time. The first surprise was that the instruments almost immediately started recording tremors nobody predicted. These were not violent, city-shaking quakes like the ones we get on Earth. They were small, deep, and strange, sometimes occurring on a rough monthly schedule. Scientists eventually connected many of them to the pull of Earth's gravity stretching and releasing the moon's interior, the same tidal squeezing that moves our oceans, just working on solid rock instead of water. A small tug, repeated for billions of years, was enough to keep the inside of the moon quietly working. The second finding changed everything scientists thought they knew about the moon's structure. For a long time, the assumption was that the moon had gone completely cold inside, solid all the way through, like a frozen stone with nothing left moving at its core. Instead, later analysis of the old Apollo data, run through modern computers, far more powerful than anything available in the 1970s, suggested the moon likely still has a partly molten layer deep inside, somewhere between the solid mantle and a small, dense core. That is the equivalent of finding a warm ember still glowing at the bottom of a fireplace you were told went cold years ago. The third discovery puzzled scientists the most because it involved quakes that seemed to come from almost nowhere. Shallow tremors, strong enough to shake dust loose from crater walls, yet with no clear tidal trigger and no obvious source. Some of the strongest shallow moonquakes ever recorded happened near the Apollo 17 landing site, in the same general region the astronauts had walked years earlier, and their strength surprised the scientists reviewing the data. A shallow moonquake with a magnitude around 5 might sound modest compared to a major earthquake here on Earth. But remember, the moon has no atmosphere to soften vibrations, and no soft soil layer to absorb the shock the way Earth often does, so the shaking travels differently and lasts differently than anything we experience at home. Think of the difference this way. On Earth, a quake's energy dies out fairly quickly, spread out and absorbed by water, wet soil, and thick air. On the moon, with no water and almost no atmosphere, that same energy has fewer places to go, so a moonquake can make the ground ring for a surprisingly long stretch of time, sometimes close to 30 minutes, almost like tapping a dry, empty bell instead of a wet sponge. That single difference reshaped how engineers think about designing future lunar bases, because a structure built for earthquake safety on Earth is not automatically safe from moonquake safety on the moon. One particular event recorded on March 13, 1973 by the Apollo 17 seismometer left researchers genuinely startled, because the ground vibrations lingered for almost 15 minutes straight, far longer than any comparable rock formation on Earth would allow. Engineers reviewing the readout years later compared the pattern to striking a tuning fork made of dry stone instead of metal, a slow decaying hum instead of a sudden crack. Nothing about that kind of prolonged ringing shows up in ordinary earthquake data back home, which is exactly why it stood out so clearly once scientists sat down and studied it properly. Thomas Waters, a senior scientist at the Smithsonian's National Air and Space Museum, has spent years studying another piece of this puzzle: tiny cliff-like ridges on the lunar surface called fault scarps. These are small steps in the ground, some only a few dozen feet tall, formed as the moon's interior slowly cools and shrinks, causing the crust to wrinkle the way a grape wrinkles into a raisin as it dries out. Waters and his colleagues published research connecting some of these fault scarps directly to the pattern of shallow moonquakes recorded by the old Apollo instruments, suggesting the moon may still be actively shrinking today, just extremely slowly. How slowly are we talking about? Current estimates suggest the moon's overall diameter has shrunk by somewhere around 150 feet over the last several hundred million years. That sounds tiny compared to a body over 2,000 miles wide, roughly the distance from New York to Las Vegas, and in cosmic terms, it truly is tiny. But 150 feet of shrinkage on a rigid, brittle crust does not happen smoothly. It happens in sudden little jumps, cracks, and slips, exactly the kind of jolt a sensitive seismometer would catch. Do you have a comment forming in your head right now about whether you would trust a future moon base built on ground that still shakes like this? Go ahead and leave it below, because comments like that genuinely help me figure out which parts of these lunar mysteries you most want covered in more depth next. Let us shift from the shaking ground to something floating just above it, because the surface dust itself does something that should not really be possible. Apollo 17 astronaut Eugene Cernan reported seeing a strange glow along the lunar horizon just before sunrise, a soft band of light where there should have been nothing but darkness and stars. He was not the first to notice it. An earlier robotic lander called Surveyor 7 had photographed a similar glowing horizon back in the late 1960s, years before any human eye confirmed it firsthand. Here's what scientists expected to find when they started digging into this glow. They expected some kind of optical trick, sunlight scattering off spacecraft exhaust or camera lens flare, something ordinary and easily dismissed. What they actually found after years of study was that fine lunar dust particles were picking up an electric charge from the sun's ultraviolet light, and the constant faint stream of charged particles flowing outward from the sun, called the solar wind. That charge was strong enough, on some of the smallest and lightest grains, to lift them slightly off the ground and hold them there, hovering like static charged confetti in a completely airless environment. Compressed down to something familiar? Imagine rubbing a balloon on your hair until strands start standing up and drifting toward it. Except instead of hair, it is fine mineral dust, the texture of flour, and instead of a balloon, it is the entire electrically charged surface of a small world with no wind to ever settle it back down. That hovering dust layer is thought to be part of what creates the faint glow astronauts and cameras have caught right at the horizon, where sunlight catches the floating particles at just the right angle. This matters for more than just pretty photographs, because that same charged floating dust is famously abrasive and clingy, and it caused real problems for Apollo equipment, jamming seals, scratching visors, and sneaking into machinery joints no matter how carefully astronauts tried to keep it out. Any future lunar base has to design around dust that does not just sit there like sand on a beach, but actively floats, clings, and drifts depending on the angle of sunlight hitting the ground that day. Try feeling this one instead of just seeing it. Apollo astronauts described lunar dust as having a strange, almost metallic smell once it was tracked back inside their sealed cabin, something like spent gunpowder drifting through the air after a firework. Nobody expected a completely airless, waterless world to leave behind a smell at all, let alone one specific enough for multiple astronauts on different missions to describe it the exact same way. That small sensory detail alone tells you how differently this place behaves once you actually touch it, instead of just looking at it through a telescope from 240,000 miles away. Now stretch the scale back out to something enormous, because roughly 4 billion miles away, out past the orbit of Neptune, the solar wind that charges up this lunar dust is still flowing outward from our sun. The same star, providing the small trickle of energy responsible for a floating dust particle the size of a grain of flour on a rock, 250,000 miles from Earth. That contrast, a force stretching across the entire solar system reaching down to move something almost too small to see, is part of why lunar scientists rarely get bored with their subject. If that contrast between the massive and the microscopic just made you appreciate this a little more than you expected to, would you consider liking this video right now? Because it genuinely helps signal to the platform that people actually want deeper science content like this, recommended to more viewers. Let us talk about the magnetic swirls now, because this is where the moon gets genuinely bizarre and where the underdog part of this story really begins. For most of the 20th century, the moon's magnetism was treated as an afterthought, barely worth studying, because unlike Earth, the moon has no strong, steady global magnetic field generated by a churning liquid core. Early researchers mostly assumed whatever weak, scattered magnetism existed in lunar rocks was leftover noise, unimportant, not worth building missions around. That assumption did not survive contact with better instruments. Orbiting spacecraft mapping the lunar surface began detecting small patches of surprisingly strong, localized magnetic fields scattered unevenly across the moon, with one of the strongest and strangest sitting right on top of that bright swirl pattern called Reiner gamma. These patches are tiny compared to Earth's planet-wide magnetic field, but concentrated in small areas, they turned out to be powerful enough to do something nobody expected from a supposedly non-magnetic little world. The second surprise came when researchers realized these small magnetic patches were acting like miniature shields, deflecting incoming solar wind particles away from small patches of ground, the same way Earth's much larger magnetic field protects the whole planet from the sun's charged particle stream. Scientists nicknamed these tiny protected patches mini-magnetospheres, essentially pocket-sized versions of the invisible force field surrounding our entire planet, except shrunk down to cover an area smaller than a mid-sized American state. The third piece connects directly back to that bright swirl pattern you heard about at the very start of this video. Researchers now believe the Reiner gamma swirl formed because that local magnetic field deflects incoming solar wind particles, which would otherwise darken the surface dust over time through a slow chemical weathering process called space weathering. Where the magnetic field blocks the particles, the ground stays brighter. Where it does not, the surrounding dust darkens normally. The result is a pale, ghostly pattern etched into the landscape by an invisible magnetic hand. Exactly the image this video opened with, except now you understand what is actually causing it. Here is where scientists will tell you they do not fully understand this yet, and it is worth sitting with, that honestly, instead of pretending the mystery is fully solved, nobody has a confirmed explanation for why these magnetic patches exist in such specific scattered locations, instead of being spread evenly across the whole moon. And models built to explain lunar magnetism have repeatedly predicted patterns that do not quite match what orbiting spacecraft actually measure. Some researchers suspect ancient asteroid impacts might have compressed and locked magnetic fields into the rock in specific spots. Others suspect a stronger, more Earth-like magnetic field existed briefly billions of years ago and left behind a kind of frozen fossil record in the crust. As of now, this remains genuinely debated among specialists, not a settled textbook fact. A paper published in the journal Nature Geoscience helped bring wider attention to how these swirl regions might be shielding the surface from weathering, giving researchers at institutions including NASA's Jet Propulsion Laboratory and Caltech a clearer framework for testing the competing explanations against real spacecraft data. That is the normal, unglamorous process of real science, competing ideas slowly getting tested and narrowed down, rather than one single dramatic answer arriving all at once. While we're on the subject of things trailing off the moon, there is one more oddity worth knowing before we head to the poles. The moon has an incredibly thin envelope of loose atoms surrounding it, far too thin to call a real atmosphere, but thick enough for instruments to detect a faint stream of sodium atoms getting knocked off the surface by micrometeorite impacts and solar radiation. That stream gets pushed by sunlight into a long, faint tail stretching behind the moon, similar in basic idea to a comet's tail, except made of scattered atoms instead of ice and dust, and far too dim for the human eye to ever notice without specialized cameras. Here's a domestic scale number to hold on to while we cross back into cosmic territory. The entire moon is drifting away from Earth right now at a rate of about 1.5 inches every year, roughly the thickness of a couple of stacked dinner plates. That sounds small, and year to year it truly is, but stretched across the 4.5 billion years since the moon first formed, that slow drift adds up to real, measurable distance, confirmed using laser reflectors astronauts left on the surface that scientists still bounce beams of light off today to measure the exact gap between the two worlds, down to a few centimeters. There's one more piece of this puzzle worth understanding before we head to the poles, and it involves the fact that we have only ever seen one face of the moon from Earth. The moon is what astronomers call tidally locked, meaning the same side always faces us, while the other side, often nicknamed the dark side, even though it gets just as much sunlight, stays permanently hidden from anyone standing on Earth's surface. That alone used to feel like a tidy, fully explained fact. Simple orbital mechanics, nothing left to question. Then spacecraft finally photographed that hidden far side directly, starting with a Soviet mission back in 1959, and the tidy explanation ran straight into a genuine surprise. The near side we always see is covered in large, dark, smooth plains called maria, ancient pools of hardened lava, while the far side is almost entirely different, rougher, far more heavily cratered, and with barely any of those same dark lava plains at all. Nobody expected one single small world to look like two completely different places depending on which half you happen to be standing on. Researchers still do not fully agree on why the two sides differ so sharply. Some models point to a thicker crust on the far side, making it harder for ancient lava to punch through and spread out evenly the way it did on the thinner near side crust. Others suggest an early, smaller companion moon may have slowly collided with the far side billions of years ago, thickening it further and permanently changing its landscape. Data from China's Chang'e Aingewie 4 mission, the first spacecraft ever to land softly on that hidden far side back in January 2019, is still being used by researchers to test these competing ideas today. Would you be willing to share this video with someone in your life who assumes the moon is a completely boring, unchanging rock? Because honestly, this is exactly the kind of story that changes how people look up at the night sky. And sharing it helps that shift reach someone who has genuinely never heard any of this before. Let us move now toward the poles, because tucked inside certain craters near the lunar south pole are patches of ground that have not seen direct sunlight in longer than modern humans have existed as a species. These are called permanently shadowed regions, deep crater floors angled just right, that sunlight simply never reaches the bottom, leaving temperatures cold enough to trap frozen water ice for potentially billions of years without it ever melting or evaporating away. Instruments aboard NASA's Lunar Reconnaissance Orbiter, launched in 2009 and still operating in lunar orbit today, along with data from earlier missions, helped confirm that water ice really does exist inside craters like Shackleton near the lunar South Pole. For decades, the working assumption among many scientists was that the moon was essentially bone dry, its surface baked clean of water by billions of years of exposure to raw sunlight and radiation with nothing to protect it. That assumption turned out to be another underdog story hiding in plain sight. The scale here deserves a direct comparison because otherwise the numbers do not really land. Some estimates suggest these shadowed polar regions could hold hundreds of millions of metric tons of water ice mixed into the soil, spread across craters and crevices near both poles. That is enough frozen water, if it could somehow be gathered and melted, to fill a reasonably sized lake, sitting quietly inside permanent shadow on a world most people still picture as a completely dry, dusty rock with nothing to offer beyond a nice view from Earth. This single discovery is reshaping serious plans for future lunar exploration, because water ice sitting inside these shadowed craters could theoretically be harvested, split into hydrogen and oxygen, and used both for breathable air and for rocket fuel, without needing to haul every drop up from Earth's own gravity well at enormous cost. A resource once assumed not to exist at all may end up being one of the most practical reasons humans return to the lunar surface for extended stays rather than brief flag-planting visits. And here's the sensory detail worth sitting with for a moment. Inside those permanently shadowed craters, the temperature can drop below negative 400 degrees Fahrenheit, colder than almost anywhere else measured in our entire solar system, including the frozen outer edges near Pluto, roughly 3.7 billion miles from the Sun. Somewhere on our own nearest neighbor, 250,000 miles away, sits a patch of ground colder than distant icy worlds, sitting billions of miles further from the Sun's warmth than we are. Confirmation of this ice did not come easily. In October 2009, NASA deliberately crashed a spent rocket stage and a companion spacecraft, together called L-Cross, into the floor of Cabeus crater near the lunar South Pole, then flew a second craft straight through the resulting debris plume to sample what got kicked up into sunlight. Instruments detected a clear signature of water in that plume, roughly 25 gallons worth in the debris cloud alone, confirming what planetary scientist Paul Spudis and other researchers had suspected for years, based on earlier, less direct orbital measurements. It took smashing something into the moon at over 5,600 solid miles per hour just to get a clean enough sample to be sure. Before we head into the final stretch of this story, would you take a second to comment with which single discovery in this video surprised you the most? The shrinking moon, the floating dust, the magnetic swirls, Or the frozen polar ice, because seeing which one resonates genuinely shapes which lunar mystery I choose to dig into next. All of these individual threads, the trembling ground, the floating dust, the magnetic shields, and the hidden ice, connect back to a single, larger point that took planetary scientists a surprisingly long time to fully accept. The moon looks finished from Earth, gray, cratered, unchanging night after night, exactly the same shape our ancestors saw thousands of years ago. But underneath that unchanging surface appearance, small forces have kept quietly working, shrinking the crust, charging the dust, shielding tiny patches of ground, and hiding frozen water in permanent darkness, all without a single obvious clue visible from a backyard telescope. Newer missions are still adding pieces to this puzzle even now. China's Chang'e program has returned lunar samples and deployed instruments studying both surface composition and subtle seismic activity, adding independent data alongside the aging Apollo seismometer records and newer American and European measurements. NASA's Artemis program is also preparing crewed missions back toward the lunar South Pole, aiming to land astronauts near those same permanently shadowed craters where the ice was first confirmed, which means some of the biggest open questions in this video may finally get answered by instruments standing directly on the ground instead of orbiting far overhead. Every additional data point chips away slightly more at the old comfortable idea that the moon is simply a dead, static rock with nothing left to teach us, a rock we already fully understood the moment humans stopped visiting it in the 1970s. It is worth remembering just how young this entire field of study still is. Humans have only been able to place instruments directly on the lunar surface for a little over half a century, a small sliver of time compared to the roughly 4.5 billion years the moon has existed. Every seismometer reading, every magnetic map, and every ice measurement we have gathered so far comes from a narrow recent window, which means the full picture is almost certainly still incomplete, with more waiting to be uncovered as instruments improve and more missions return. That old idea was always going to be wrong, honestly, because very few things in nature are ever as finished and unchanging as they first appear from a distance. Stars that look perfectly steady in the night sky are boiling with violent activity up close. Mountains that look permanently solid are slowly eroding, grain by grain, into rivers and oceans. And a moon that looks like a silent, frozen leftover from the early solar system turns out to still be shrinking, still trembling, still magnetically shielding tiny patches of its own dust, right now, tonight, while you are watching this. The moon does not announce any of this the way a storm or a volcano would. There is no thunder, no lightning, no obvious eruption to point a camera at and prove something dramatic just happened. The proof instead sits quietly in decades-old seismometer recordings, in faint magnetic readings mapped from lunar orbit, and in patient, careful measurements of craters that never once see direct sunlight. Understanding does not always arrive as a bang. Sometimes it arrives as a slow, careful signal, buried in data, waiting patiently for someone curious enough to notice it. Think about what that really means the next time you step outside on a clear night. The same pale light bouncing off that gray, familiar surface has been traveling across roughly 240,000 miles of empty space, bouncing off ground that is at this very moment quietly shrinking, faintly trembling, magnetically shielding a patch of ancient dust and hiding frozen water no sunlight has touched in longer than human history stretches back. None of that motion is visible from where you are standing. All of it is real anyway. And that, in the end, is the real story hiding behind that swirl pattern this video opened with. What once looked like a strange, unexplained smudge painted onto gray dust turns out to be a visible record of an invisible magnetic shield, quietly protecting a small patch of lunar ground from billions of years of solar wind, one charged particle at a time. What once looked like a dead, silent world turns out to be a body still shrinking, still trembling, and still hiding secrets inside its own permanent shadows. We assumed the moon had nothing left to teach us, and that assumption turns out to be exactly backwards. The ground beneath those old Apollo footprints is still moving right now in ways too slow and too quiet for any human ear to ever catch directly. Somewhere near the lunar South Pole, ancient ice sits untouched by sunlight, older than most of human civilization, waiting in darkness that has never once been broken. Somewhere near Rainer Gamma, an invisible magnetic shield is still holding back a slow tide of solar particles, one charged grain of dust at a time, exactly as it has for millions of years without anyone noticing until we finally learned how to look properly. We used to think finished, quiet, and unchanging all meant the same thing when it came to the moon. Now we understand those are three completely different qualities, and the moon only ever really had one of them: quiet, while shrinking, trembling, shielding, and hiding ice this entire time, patiently, in full view of every person who ever looked up and assumed there was nothing left to discover. A rock does not have to move fast, or loudly or dramatically, to still be alive with change in every way that actually matters to the people studying it. A few people ever stop to consider that the ground under those old boot prints is still settling, closing tiny gaps millimeter by millimeter, decade after decade, long after the astronauts who left them went home. We all look up at the same pale shape most nights without a second thought, and yet almost none of us ever pause to consider that it is quietly still becoming something slightly different than it was the night before. Next time you glance up at that same familiar gray shape hanging in the sky, remember there is a whole quiet world of motion happening, just beneath that stillness, waiting, as it always has, for someone curious enough to keep watching.